What I really want to talk to you about is how can we build machines that will sort of take all the boring stuff that you're doing away? How can we do this? At the same time, I want to talk a little bit of a story about don't believe people that are pessimistic. You know, think about sort of the really big things. When you think about robotics, you might be thinking about, I actually thought about having my opening video, what Josh was talking about, the trailer for Terminator 3. But then I remembered there was something about copyright and a few other things that sort of did not allow me to do that. But when you think about robots, what are you really thinking about? Many of you are probably thinking about the Hollywood story about machines going rogue. They're going to come here and, you know, we have to have Will Smith run in and fix a small bug. That's not quite what robotics is about. But one of the typical applications are these big industrial applications where we've seen them traditionally do dirty, dull, and dangerous stuff. You know, the stuff that we don't want to do, the stuff that we're not very good at doing. So robots have an immense amount of precision. They can lift very heavy stuff that we're not very good at lifting. So that's one of the places where we've seen this. Another area where you might have seen the inspiration was sort of right about the time when I got born. There was a very famous cartoon on television with the Jetsons, and they had this Rosie, an amazing robot that would do all sorts of things in the home so that you didn't have to do this. That's the kind of systems we're trying to build here. So we did a big survey and we asked people, what do you really want help with in your daily life? Can any one of you guess what you really want help with in your daily life? Cleaning the house. The number one thing is actually doing the laundry, which, you know, that would not have been my number one thing. You know, you can go and have that done by other people, but that's very big on it. Number two is cleaning your windows. You know, so so we're seeing this out there. How can we help you in your daily life to get to sort of that functionality? So that's what I want to talk about. Before this, I want to talk sort of one of the reasons why we're doing this is our changing demographics. If you look at this graph, you should see two things. You should see the bad news and the good news. The good news is Japan is much worse off than we are. The bad news is that's not really much of a consolation. You know, there's going to be twice as many people above 65 within the next 20 years. This is going to have huge consequences. In terms of healthcare, we live longer. Some of us are slightly obese, so you know, you might have to think about what are we going to do about this. Some of you might not be able to retire as soon as you've thought about because the workforce is reducing, but also we lose mobility. So we might have a harder time getting around. So the question is, how can we help you do this? That's the kind of technologies that we're interested in studying here. Before I do this, let me take sort of a parallel story. So, you know, quite a number of years ago, we started building these very large computers. And Thomas Watson, the CEO of IBM at the time, said, our current estimate of the world market for these are 5. He was a little bit off. And then, you know, we got personal computers. And the CEO of Digital Equipment, one of the big computer providers at the time, said, we don't see any applications for these in homes. He was also a little bit off, you know. So we sort of seen this, that people are, no, this is not going to go anywhere. And, you know, today we see them sort of, they're omnipresent. They're everywhere. So we're seeing this technology coming out. Initially, people are scared. It's not very good. It's very expensive. Do we really want to do this? A parallel story is the phone. When the phone came out, Western Telegraph put out a business memo, said, we don't see this communication mode as having any relevance to everyday people. They were probably a little bit worried about the telegraph, and clearly we got this. Then we got the cell phone, or the mobile phone, and everybody said, this is only relevant for traveling business people. And you know, most of you in the audience today probably has at least one cell phone, and several of you will have 2 cell phones. So it's really changed dramatically. The other thing that's changed dramatically is that for most of you, you don't care about this button. It's all the other things, you know, you're on Facebook, you're on Twitter, you're on all of this, and so, oh yeah, that's right, I can talk to people as well. You know, so we've sort of gone away from this, you know, it was not invented for this, it was invented for you to be able to talk to other people. We don't use it anymore, it's sort of become an asynchronous. The nice thing about this is that you can use this to transfer information, so you're tweeting and you're doing all of this. The one thing it's missing is physical interaction. You can do physical stuff with this. That's where robots come into play. We can use robots to do the same things. We can interconnect them. We can do all of this. So as an example, we have a robot in the lab that uses Google goggles. If you don't know what Google goggles is, it's one of those things where, whenever we go to a restaurant, I take a picture of the wine bottle and it will immediately tell me, where can I buy this bottle of wine? What can I buy it for? What was the review from this? And it will tell me immediately how much was the restaurant actually putting up the price on this particular bottle of wine. But you can also use it. If you go out here and take a picture, it will tell you you're on the Emory campus, you're probably in the Woodruff building. So we can use this technology to do really cool things. So that's where we come back to sort of the robots. How can we use this in our everyday life? We started out 50 years ago building these types of robots, extensively used for doing welding, gluing, heavy lifting. So if you go into a car factory, the first two areas, the plate shop, the paint shop, and the welding shop, are all with robots. And then the rest of it, we still have a lot of people working there, but these are jobs that are really miserable. You don't want to be there. So great use of robots. The other area where you might have seen this is in entertainment. It's an enormous number of robots that are being used out there for doing various kinds of entertainment applications. If you go to the Harry Potter exhibit at Disney, it will actually have 40 robots that's doing the roller coaster. And if you go to, I think it's Universal Studios, you can get a roller coaster on a robot, sitting at the end of a robot and it's doing this to you, which is pretty cool. But there's still some very serious applications. Another area where we've seen these recently is in terms of doing material handling and stuffing things around. So if you buy something from Amazon, Amazon's objective is to make sure that by the time you get home, it will be in your mailbox. We want to get to this instant gratification where you order something on, almost by the time you press the button, somebody knocks on the door and says, here you go. And the question is, how can we do this? And one of the big challenges with these with regular warehouses is that you waste a lot of land. So if you look at this, there's a lot of air in this. Said, yeah, that's nice. People can go around and do all of this. The problem is that half of the space here is empty. If you're buying land in New York, Boston, or in the middle of Atlanta, it's ridiculously expensive. We can use this to move this around so that rather than having stationary shelves, we move around the shelves and you stand still. By doing this, I can reduce the amount of space by 2/3, and I can double your handling rate so that you can actually get to this much faster. So that's an area where we're seeing this technology come out. Because it was so immensely popular, Amazon decided to buy this company for $700 million. So, some really interesting opportunities out there. For these applications, we've also seen, you might have seen humanoid robots, very popular in Japan. In Japan, the ultimate thing you can do is build something in your own image. They're a little small for my size, but okay, they were doing this. So 2 years ago, when we had the disaster in Fukushima, we decided we probably have to send in these robots. These robots are not very good at walking on rubble. So we actually sent in an American robot. So they sent in this robot. It was able to go into the nuclear power plant, go and do some readings off the meters. It could do basic handles of a few sort of knobs to be able to tell you, is this safe? Can I do some immediate shutdown so that we can do this very fast? Now we're seeing a huge initiative in the US to do the same things. What if we had an earthquake somewhere in the US? We would want to be able to close this down very rapidly, be able to really get and do the right things. So you're seeing these applications all over the place, initially from the industrial area, going into doing these application areas. So another area where we've done this is that was where we initially got into the homes, was on vacuum cleaners. So I was actually on the team that developed this robot. So I can say I've developed a robot that truly sucks. This is a good thing, So we've sold 6 million of these robots. And as we did this, we wanted to study, how does this actually impact people? How does these robots, how do you interact with them? So we did a number of studies. So we went out to a number of homes across the country. Here is a place where we went to the boys and the girls' room. You can guess which one is the girls' room. And we went in and we gave them a robot. And the kid said, yeah, it's not for us. And then, you know, a few days later, or a week later, we came back. The boy had realized this is really cool. So, but he had to clean up his room to be able to do this. The girl was, yeah, no, I don't think so. But so we were, okay, this is clearly a gender thing. But when we came back 6 months later, they got this. So, you know, the take-home story here is, if you buy a robot, your kids will start cleaning their room. Or maybe not. But, you know, there's some very interesting opportunities here to figure out how can we actually leverage this technology. There's 6 million of these out there today. So we're starting to see the really simple tasks. We're slowly getting to where we can help with a variety of other things. So why is it hard? Why didn't we have them already? Some of the reasons why it's hard is that we have to be able to build these robots. We have to be able to endow them with a degree of intelligence. Intelligence implies that they have to be able to perceive the environment, they have to have cognitive capabilities, and they have to be able to sort of interact with the environment. And some of the things is that if you think about it, our language is sometimes ambiguous. So look at The Simpsons, you know. Lisa is clearly talking about math, you know, and Homer is clearly thinking about food. They both talk about pie. So, you know, especially in the South, you know, it's sort of pie, you know. So that would go very well here, you know, thinking about how do we make sure that if I give it a robot, you know, I want to know if I say, bring me a pie, if it comes back with this, I'm going to be really disappointed. You know, so how can we make sure that we can actually do this? So that's been one of our big challenges, endowing it with a way of understanding language. One of the other things is for it to be able to understand so that we can do perception, we can recognize objects. This is sort of where state of the art is today. We can even see transparent objects, we can track them, we can do this in real time. The other thing we've gotten to is how can we interact with the physical world? So, you know, normally if I was going to ask you, how long will it take for you to light a match? You will probably say, it doesn't take very long. Well, you're about right. This is an experiment where we had a human do this, and they would go in, they would light a match. You can't really tell here, it's about 5 seconds. I'm now going to take this person, anesthetize them, so that they have no haptic feedback. It's no feedback. It's the only thing that we change. You can see, you have your regular muscle control and everything else. I've just taken away your fingertip feeling. How much worse do you think they're going to do? The same? Going to be twice as long? Well, the magician might know this answer, but you know, what do you think? How bad do you think it's going to be? 20 seconds. Okay, let's see. See, there we go. Uh-oh, this is a little bit nasty. You know, it's not so easy to pick these things up. Damn, you know. And I'm a vision guy by training. I was very disappointed. I was like, come on, you know, I can do this. So it took 25 seconds. So we're incredibly relying on this very thing, sort of fingertip sensing. So we're now building robots where we can actually get this fingertip sense in there. The same, you know, if you're going to have to, I'm always saying, you know, by the time I retire, I would like to get a robot that would allow me to get out of bed, take a shower, prepare a meal, and, you know, do things. But I'm not sure I'm ready for having these help me go to the restroom. You know, sort of, you know, with that kind of fingertip feeling, I would be a little bit worried. You know, so we're seeing this. But that sort of brings me to, there are some of these very interesting projects that we're looking at. So well, before I do this, here's how we do training. So this is my colleague, Henrik.
Okay.
So training the robot Simon. So Simon was designed to be humanoid so that people would have a social relationship with it. It can look at you. It has colored ears. The color of the ear will tell you whether it's paying attention or embarrassed. The red ears are the embarrassed part.
I see.
And you can basically see we can go around and we can train it. So this would be like if you were training any other person and we can do this. And it's actually remarkably powerful to be able to do this. So we can build these kinds of robots and actually get very good. We can even, you know, if it's confused, it can say, I don't get it. So, you know, when I see the magic show here, you know, he would say, no, I'm sorry, I don't get it. You have to tell me, how do you get this into the bottle? So we can use this kind of intelligence to get it. And an example of the kind of tasks we've been doing was that we had a project at Georgia Tech jointly with a company called Willow Garage that's called Robotics for Humanity, where this guy, Henry Evans, saw one of our robots on CNN, and he's paralyzed from the neck down. And he said, it would be amazing if I could get one of these robots. And you know, he wanted to have a little bit of help in his daily life. Can any one of you guess what his first task was that he would like to have help with? Sorry? Food. No, it was something even more basic than that. You know, he would like to have a robot that would allow him to scratch himself. You know, very simple functionality. He's sitting there and it's really itching, you know, can I get a robot that would sort of do this? For him, that would be a game changer. The other thing he would like to have help with was basically being able to shave himself. He was not happy, he had an electrical razor, he was like, this is not quite what I would like to do. Can I just have a robot that would allow me to do this myself? And now we finally also gave him a robot where he can feed himself and he can do simple things like go and do this. So very recently at Halloween, he did trick and treat at one of the local malls. He could take this robot out, he could control it, and he could give candy to the kids. Which is, you know, amazing that we're getting to where we can take this technology, we can move it out, and it really helps people in their daily lives. These are the hard parts, you know. Now I want to get to where we can actually do the ironing and we can do all of this. So our big prediction is that you're going to get one of these robots in your home anytime soon. So when people say, well, it's really difficult, they are getting down to a price that's very inexpensive and you can get this technology out there. So all the dirty, dull, and dangerous stuff you do in your daily lives, we're going to get rid of. And with that, I'll just say thank you.